Okay, let's look at cosine and draw conclusions regarding the time period of cosine. Because it's a function, we can sort of make a table. So this is another approach for finding out the plots or the graphs. Say sine and cosine. Let me mark these values already. So pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. That's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so they are evenly spaced. 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Just going to quickly repeat that right here. Pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Now because these are in radians, I'm going to go into mode, change things into radians. Let's do the sine. We already know sine 0 is 0. We know sine 90 is 1, so that's pi over 2, right? That's 90 degrees. So pi is 180, so that's 1. Sine of pi, which is 180, is going to be 0. And sine of 2 pi is also going to be 0 because that is 360 degrees. Right? Now again, if 90 degrees is 1, then the diagonally opposite to 90 is 270. We expect it to be 1. Oh, sorry, that's not in radians. So 3 pi over 2 is negative 1. Which is the sort of our expectation, right? It goes from 0 to pi is quadrant 1 and 2, so sine is positive. And from here to here it's negative, and the values sort of repeat. So let's find these. Sine of pi over 6 is 1/2. Sine of pi over 3 is root 3 over 2. Sine of 2 pi over 3 is again root 3 over 2. Sine of 5 pi over 6 is 1/2. Sine of 7 pi over 6 is negative 1/2. Sine of 4 pi over 3 is negative root 3 over 2. Sine of 5 pi over 3 is negative root 3 over 2, and sine of 11 pi over 6 is negative 1/2. Let's verify our claim. The value 1/2 occurs 4 times, as we expected, 2 of them negative, 2 of them positive. Root 3 over 2, 4 times. 2 negative, 2 positive. The only exception is the max and the min value. 0 happens to occur only 3 times, and 1 occurs 2 times. One's positive and one's negative. And because 0 has no positive or negative, it doesn't make sense. It's just what it is. Let's plot these values. So I have 0 at 0, then I have 0 at pi, and I have 0 at 2 pi. Let's call the max value 1, negative 1. So at pi over 2, I get to this max value, and at 3 pi over 2, I get to this min value. Half, it's roughly there. Root 3 over 2 is over there. Then I get another root 3 over 2, and I get another half. Then I get negative half, negative root 3 over 2, negative root 3 over 2, negative half. If I connect this point, then they are approximately going to look like that, which is surprisingly similar to the conclusion we drew before. Now again, as you can see, for any point, it's going to have 2 positive and 2 negative, and they are going to represent the square inside the circle. And you can go ahead and finish the same thing for cosine, and what you should get for cosine is going to look something like that. Okay, slightly different, but try and complete the table and find out exactly what it looks like. And in fact, the time period for cosine is also going to be 2 pi. Okay, now I'm going to end this video here. See, in the next video, we're going to look at transformations of graphs, which is something you have seen in Math 135. So we're going to revisit them briefly and then apply those transformations to trigonometric graphs.